So welcome. Thank you for joining our Tech Talk. Today we will be walking through building, testing, and deploying an OR-Tools MIP model in Python. Our presenter today is Marius, decision scientist here at NextMove. And we have an agenda on the right here. I will quickly speed through some orientation about NextMove and decision ops. And then Marius will dive right into a demo where he will show us how to customize a MIP model in Python, as well as deploy it to production. And at the end, we will, of course, save time for questions. But throughout the whole presentation, feel free to ask them in the chat or use the Q&A feature. Just remember to toggle between everyone and host and panelists, depending on who you want to ask the question to. Encourage you to ask it to everyone. We have a bunch of folks from the team on the call with us today, so they'll be happy to answer questions along the way. Great. So a quick introduction to the NextMove platform. NextMove is a decision ops platform for building, testing, deploying, and managing decision models. And as you can see, we offer domain-specific solutions that can be customized. And we also offer complete customization with our SDK. So you can see we have a CLI, which is our workflow management interface, as well as a console. So that allows you to manage model versions, do things like view run history, perform tests, and really collaborate with your team in the console. So where does NextMove sit? This is a high-level look at how we fit into technical stacks. On the left side, you can see there are inputs like operational data and prediction, and those feed into NextMove. So we have different layers here, and at the bottom, you can see that we provide an infrastructure layer for hosting and testing. In the middle, we have an optimization layer. So we have integrations with modeling tools and solvers like OR-Tools and Highs. And then at the top, we have an application layer, and that's for specific use cases. So from there, solutions are generated and output is sent to operational tooling like customer apps. So what is decision ops? You probably heard me say that earlier. We like to think of decision ops as kind of like machine learning or ML for optimization. So there's really a similar level of importance put on having reproducible experimentation and collaboration across teams. What you'll see is slightly different is instead of training models, we are testing and tuning them. So we will see this come to life a little bit in Marius's demo. And I'll do a little brief run through about the NextMove OR-Tools integration. So you can bring your work in progress or your completely built OR-Tools model and use the modeling tools and the solvers that ship with OR-Tools. So you can use those for use cases like routing, scheduling, packing, and beyond. And then you can deploy that all in a few clicks, and you can test and manage your models and do that all with NextMove. So we drew some inspiration from a previous tech talk, as some of you may have joined. Our CTO, Ryan, presented on 3 logistics models that all kind of fed into each other, starting with demand forecasting, fed into shift scheduling, and ended with the VRP. If you'd like to check that out, that's on our videos page. But we did take some inspiration from that to do something similar for today. So today we're focusing even further on shift scheduling, and we're breaking that into 2 commonly performed steps, which are shift creation and shift assignment. And today, both of those models will be done in MIP using OR-Tools. So we'll start assuming you have a demand forecast. So you've gotten that through some model that you've already created and run. And Marius will have used that in a shift creation model, which he's deployed, and he'll really dive into the code more specifically for shift assignment. So with that, let's dive into the demo from Marius. And while he's getting set up, I do suggest folks hop into kind of a full screen mode. He's going to be doing some live coding for us, so that'll be the best way to view that. So over to you, Marius.
Yes, thank you, Renu, and also welcome from my side. So like Renu already explained, we're gonna be looking at shift scheduling today. And so this is the repository where all of this code already lives. And so like Renu mentioned, the shift creation is basically like the first phase of this 2-stage shift scheduling part. That app already is implemented, lives in here. Shift forecasting is another app that actually also lives inside this repository. And the missing or the gap that we have is the shift assignment model that we need, and that's what we're going to develop live today. And to pick you up to some extent and, you know, frame this a little bit. So we basically, you can assume that we have like a demand, some kind of demand. This is how realistic this is. That'll be that, but you know, you can decide for yourself. But this serves us well today. So this is a demand over a week. This is without qualifications, which the model will have to support though. But so we will have the demand for a number of employees over a schedule over the period of a week. And we always have some kind of background demand, even during the night, at least on weekdays, for some kind of on-call or something, you may assume. And then even during the weekends and over the week as well, we have like these spikes during the day that we need to cover. And this you can also find visualized in this plot. So this is like this background demand with a number of employees that need to be available during that time and scheduled. And then we have these random demands during the day that cause this peak. And to cover all this, we have a lot of these predefined shift templates or shift types that we need to activate and determine how many of them we need to cover this demand that we have. This is done by the shift creation. And so the result of that will be all of these different shifts that we need then employees or need to assign employees to. And this is where we take over and do what we are going to do today, which is implement the shift assignment model. So let's start with the output of the upstream app, which is the shift creation. And the output of, or the solution of this app is basically all of the different shifts. And so these shifts have like a start time and end time, may require a qualification. This one doesn't, and require a certain set of employees or number of employees to work on this shift. And then the other part is our workers, or are our workers. This is from some kind of database or whatever, where we have all of them listed. They have a number of qualifications, may have these. They may need to may have some rules defined, which is contractual agreements, regulations, etc., and a number of availabilities. So when they are actually available for work or maybe out. And to combine those, we'll use this weird, let me move this over. We'll use this weird JQ statement so that you can see actually that I'm combining just these two worker JSONs, or the content of the workers JSON, which is the regulations and other requirements and the workers themselves, as well as the solution of the upstream shift creation process. And this will be the input of what we'll be creating. And this helps me a lot when I develop a new model to actually already have like the input, you know, the notion of the input. So the input will be our workers. Again, we've seen those. Then some rule requirements. This is a very simple model. This just has a requirement of 11 hours of rest between two shifts. And there may be obviously more. Shift scheduling is like very complicated, it can get very complicated, especially around regulations and contractual requirements. And then we have all of these shifts that we need to cover with our workers. So let's do that. I'm going to take this input, and the first step that I'm going to do is I'm going to next move SDK init-t, the OR-Tools template. This creates the OR-Tools template, which we're going to use as a starting point for our model. And this template, I will already rename it to shift assignment, because that's what it should do now. However, the template is based or tailored around a knapsack problem. So we're trying to stuff like cats and dogs into a knapsack, apparently. But this is not what we're going to do today. So I'm going to paste over this input, our input, which is the one for shift assignment. And then we can immediately head over to the model itself, or to the code. And most of this is actually, obviously this is based on knapsack, but most of this we can actually recycle for our shift assignment as well, because our shift assignment app also has an input, needs to write an output, may have a max duration, because if it runs for too long, the server should still stop. However, this is obviously specific for the knapsack problem, so we're going to remove that. The whole process, though, will be untouched. We read the input, we solve it, and write the solution back to the output. So that will stay the same. All the magic anyway happens within the solve function. We'll still create the solver. This will stay the same. This is the model code of the knapsack problem. This obviously needs to change. And then also we need to change how we transform the solution back to the output. And apart from that, those two gaps will be the ones that we mainly need to fill. But there's one small other thing that I need to copy over quickly to cheat a little bit, to have some helper functions. Let me copy them. I'm going to paste them below here and quickly explain what I'm doing. So we have an additional function for converting the input to a format that fits the model code a little better, mainly because we need to convert the strings, the datetime strings, to actually proper datetime objects. We need to set some defaults. We need to merge some availabilities if they're head-to-head, etc. So that's what we're going to do. And then we also define a custom serialization function so that we can deal with datetimes easily. That's actually something that I need to use down here. So I'm quickly going to do this. And Copilot will help me a lot today, which is great because I'm a little sick. I hope I'm not sounding too nasal. And I guess in some years, Copilot can just do the demo for me. But cool. So let's start with the model code. The main part is, and Copilot is actually right about that, is that we apply this input conversion. And then we're going to create the variables expressing whether a worker is assigned to a shift or not. We call them xAssign. It's going to be a dictionary of variables, and we create one variable for each worker shift combination. And so the indices will be the ID of the worker and the ID of the shift. And we're going to create a bool variable for each of those. And this will determine, or basically express, whether this worker is assigned to the shift or not. And another interesting note here is this simple model won't have an objective right now because we're basically requiring all shifts to be covered in the end with the workers that we have. So I'm going to omit that, but obviously if you have a more complex model, you will have more constraints, you will have further or an objective at all or further objective components. But for this one, for this example, this is gonna do. So we're gonna ensure that each shift is assigned to exactly one worker, correct? And so we need to get over all these add a constraint for all of these shifts, which is going to be the sum of all the assignments of workers, and that shouldn't be equal to 1, but instead should be equal to count, it was called, right? So that's that, and that is our first constraint expressing that we're gonna schedule so many employees in the shift as they are required, right? And there's going to be a lot of other constraints, which I don't want to implement right out here live because it's not so long. We don't have that much time, and I'm probably going to make mistakes at some point. So let's copy them over. But I will quickly walk you through them. So the next one is also a very simple one. If the worker has a minimum shift requirement or maximum shift requirement, then we also need to adhere to that. We simply go over all the workers again, add a constraint for each, and that will just be the sum of all the possible assignments of shifts. And that needs to be, in this case, greater equals minimum shifts, in this case, smaller equals maximum shifts. So also very simple. Then the next one is what you've seen earlier, the 11 hours of rest, or depending on the worker contract, maybe more or less. So for every one of the workers, we also need to make sure that that is adhered to. We're going to make sure that we only define it as often as necessary. And so then we need to check whether these two shifts that we compare here are too close to each other so that these 11 hours of rest would be violated if both of them get activated. And if that is the case, then we actually make that a constraint. So basically, both of these assignments of these shifts for the worker need to be smaller or equals than 1, so we can just do a schedule 1 of them. And then another one is that we need to respect all the availabilities of the worker. So we again go over all the workers, all the shifts, and make sure that if the worker is not available during that time, then we will simply bound this variable for this worker to this shift to 0, so it cannot be activated. Obviously, again, you can do this differently. I'm relying on the pre-solver here to figure this out for me, but another option would be to not even add this variable in the first place, obviously. But then the last one is the qualifications that I already mentioned. So every one of these shifts may have a qualification. So we also need to go over that and check all the combinations of workers and shifts. And if the shift doesn't have a qualification at all, then we can just ignore it. If the shift has a qualification, but the worker doesn't have any, then again, we forbid this assignment. And as the last part, obviously, if the qualification is not in the qualification that the employee offers, then we again disallow this. Okay, so this is already like most of the model that we had to implement. Again, in reality, you will face more complex constraints, more objectives that you want to track and optimize for, etc. So this is a quite straightforward and simple example, but yeah, it will serve us well as an example. And now that we solved it, we also need to transform the solution into our expected output format. And for that, we're gonna define a schedule. And we also need to track, or I want to track the active workers and the total workers for statistical purposes, like later on the output. You will see that in a minute. And we only can actually return a solution if we either got an optimal answer or at least a feasible one, which would mean the solver ran out of time. And now let's transform it back. So for this, I'm adhering to a format that we specify as a convention. If we adhere to that, we will actually get a visualization of our planned shifts in the console. So that's why I'm using this kind of format. Let's do this. And the format is pretty simple. We basically use the start time of the shift, and we don't need this actually because we already defined this custom formatting func that we're applying. Then this is not too far off. So we want to have the worker ID, and we want to have the shift ID, and this should be everything. Obviously, I need to range over the workers, the shifts, and I only want to have them in the output if they are actually planned. In that case, that would mean like greater 0.5. Obviously, this is a bool variable, so yeah, that means it's 1, but just making sure that there's no rounding weirdness or something. That's why I use this style. You may use a different one. All right, let me check a bit whether I'm doing the right thing here. So oh yeah, one further thing that is required is I actually also want to have the number of assigned, assigned workers. And that I'm going to determine by taking the length of actually the set. And yeah, Copilot is writes itself, basically. So we're looking basically for all these assigned shifts that we just, collected, and then extracting the worker IDs from them. And the set of those will be all the unique worker IDs, aka workers, and the length of that will be the number of assigned workers. So that's pretty simple. And the next one is active workers, and that is going to be, actually we can just reuse what we just defined here, and the total workers is simply the length of workers. Right. So these statistical variables I want to have in my output. We actually have a section that is useful for experiments. So if you run experiments on our platform, you can leverage this. So in all the views of the values of the solutions and so on, of the benchmarks, etc., you can have custom values and custom metrics, KPIs in them. And I'm interested in the active workers and the total workers so that we see them always. The solution value, like I said, we're basically just satisfying. We're not really optimizing or minimizing, maximizing. So I can just put a 0 in here, I guess. And the last step would be to actually return the schedule as the solution, the only solution. And that is all. We can already run it. One thing I want to copy over though from my cheat sheet is some more logging so that we can actually see some more of the output, or more interest, the output actually, in a more interesting way. And I'm gonna copy this over here as well. And right, so that's the model already done. So I need to change directory to that, and I can already run it. Main.py input, we're going to use the input JSON that I just copied over, right? We can run it, and this gives us the solution. And as we can see, I apparently didn't make a mistake, so we have scheduled workers. So John Anello, for example, will work the late electrician shift basically on 8th of December from 14 to 22. Nice. And we also have our active workers 57, total workers 63. Nice. So we basically now need to create this app actually, or let me first push the code for this. Adding shift assignment. Cool. And now we also want to next move app create -a shift assignment. We want to register this app also with our backend and with our platform. So shift assignment will be the ID. Shift assignment will also be the name, and the description will be assigns employees to shifts. Very creative. All right, then next move app push -a shift assignment will snapshot the code like it sees it and bundle it up as an artifact that we can then make runs against. As you can see here, there's even curl statements. You can already push things or throw your inputs against this endpoint that already exists and was created for you. And that's what we're going to do, but with the help of next move Cly, because it's a little more pretty. So next move app run -a shift assignment -i input and -w, so that we wait for the input for the solution to return and print it immediately. And this may take a little bit longer, especially the first time, but gives us the same solution back. We have 57 active workers, 63 total workers. Again, how realistic this is a different discussion. But anyway, we have our worker scheduled, and this time not on my local machine, but actually on platform. So this is great. One last step I'm going to do over here with Cly is next move app create version create. So for the shift assignment app, I'm going to label this last artifact, this last snapshot of the code that I just pushed with a certain label so that I can reference this version later. And for this, I'm going to use this small script snippet. So for the version ID, I'm going to use this git describe, and this works very well. So this will, in this case, return just the SHA of the revision, which is great, right? Because then we can find this version again in our code base. So it's always nice to include that in the ID. And as the name, we're going to do the same simply. So creating the version. And now that we're basically done with the code, we can head over to the console. And we already can see shift creation, shift forecasting are in here as the apps. They have been pushed before, they ran already, but we also now have a shift assignment app. So that's great. And also I can head over to the run, and don't be surprised, there's more runs here because I tested this before, but this one is actually the one that I just sent. So I can open this up, and if I didn't do something wrong, I should probably even see the visualization. We'll see that. Yes. So this ran, and we can see that it also renders the output. So this is where our employees were scheduled, etc., etc. So that is great. And we also can find our version, the one that I just pushed here. And one last step that I want to do is I also want to have instances. So if you think about versions, that's basically like a snapshot of your code that lives on our platform. And the instance is basically where you throw your runs against, right? So could be different ones, but basically one instance refers to one version of your code, of your model, and potentially also some configuration. And like I said, can be referenced when you actually make runs. So it's useful to have, for example, a production instance. So production, and obviously handle with care, please. And we're going to use this first version that I just pushed. Potentially configuration could go in here as well if your model reacts to that. We're going to ignore it for now. So I just created this production instance with its version. And I'm also going to edit the app, set this production instance as the default one. So if you make runs against this app without specifying the instance, they will go to the production instance, which is great. And then one further one will be development. So also let's create the development instance. And that's going to be used for testing and benchmarking, etc., which is discussed in other tech talks, other videos that we already shared. So maybe refer to those, because I probably won't be able to cover anything of that. And now that we created all of these instances, I'm going to show you one last thing, and that's going to be the push workflow in here. And this already pushes the other apps and will now also push the shift assignment app. So there's a matrix strategy in this workflow. It will run whenever we push to main. Since I'm working on it alone, I'm currently just pushing against it, but obviously you would also run this after merge and after you reviewed your PRs. But anyway, so this will push all these three apps by checking out the code, of course, installing Nextmove CLI, configuring Nextmove CLI mainly for an API key, and then most importantly, it will push the app again, which I just did manually. So snapshot the code, upload it, then create a version of this code that we just pushed, and update the development instance to use this new version. So it's a minor change or tiny change here. I'm gonna push this quickly. Push assignment automatically. Typo, but it's okay. Push this. Now, if we head over to the repository again, we can see in our actions. Come on. There's actually under push a workflow running that is pushing all three apps and updating them. This is useful, like we described, or Renu referred to also in decision ops, etc. So you can take that further. Obviously, this will track and create all of the different snapshots of your solver, all different versions that ever have been merged to your main branch. This can be very useful when you experiment and do automatic experiments, etc. But whatever you imagine, however your individual workflow looks like in the end, may vary a little bit. But while I was talking, basically all of these three apps were pushed. And this is the new version that was just pushed. And if I go over to the versions, then I need to refresh quickly. I can find this. So this was automatically pushed from the workflow. The development instance already uses this one. And the production instance, I could simply edit and use this one as well, save it, and now I even updated production. And that's how I deploy to production, I guess. That is all from my side. Thank you.
Wonderful. Thank you so much, Marius. That's quite a lot to squeeze into the time slot we had today. Very impressive. So what did we see happen just now, and what are the takeaways? So we watched Marius customize an OR-Tools MIP model in Python. So we saw him actually create the shift assignment model and deploy it to production in just minutes. And we also at the end there saw how you can really incorporate tools like GitHub Actions into your developer workflow as well. Okay, so we have a bit of time for Q&A. I think we're just at the end here, but I do want to squeeze in a couple of questions. So the first one for you, Marius, is where can I access the code that you are using today for the Tech Talk?
Oh yeah, we're actually thinking about publishing that as templates. Like I just initialized this Nextmove SDK-init OR-Tools template, which is like the knapsack thing. We would probably have like something like shift assignment and shift creation potentially, so that you could start from them immediately.
Perfect. Yeah, so stay tuned for that. We will notify people when those are live, and that'll make it even easier to get started. But for now, just create a free Nextmove account. You can start with the OR-Tools template that Maria started from as well. All right, I think we have time for one more, and that question is, which solver are you using to solve? So I'm assuming that means for shift assignment, but it might have been both, used the same
Yeah.
one.
This one, the provider was Skip. You may have seen it in the code floating by quickly, but this one was Skip, so free one.
Perfect. All right. Well, I think we should probably wrap it up here. But if you asked a question that we didn't get to, not to worry, we will absolutely reach out to you via email to make sure that we continue that conversation and get your question answered. So thank you again for the engagement. Really great to see. One quick fun note that we're all excited about from the Nextmove side is that we launched on Product Hunt today. So if folks want to go learn a little bit more about Nextmove and engage with the community there, the link is here, and I think that'll be dropped into the chat as well for easy clickability. But yeah, feel free to hop over there. Yeah, that wraps us up for today. Like I said, please go create a free Nextmove account and poke around. You can get started today with an OR-Tools template. Talk to our team. We have folks like Marius who are wonderful to talk to, who love talking about optimization and the workflows that people use. So reach out to us and check out our other videos and blogs. We also have wonderful documentation that walks you through a lot of the use cases. So please check out those resources, and thank you again for joining. We will see you next time.
Yeah, thank you.